Hello, Math Studies students, and welcome to your online lesson. Today we'll be talking about creating quadratic equations from word problems, and we'll know we're successful when we can efficiently solve word problems involving quadratics. So I've put together a list of steps to help guide you in creating a quadratic from a word problem and then making sure that you solve it successfully. So the first thing we need to do is make sure we're actually reading the problem. And then our goal is to translate those words and the given values into a single mathematical equation involving an equal sign. And when I say single mathematical equation, the last time we were solving word problems, we were doing linear systems where we'd have multiple equations, often multiple variables. This time, just a single mathematical equation. And if it helps, we can use a picture. We want to ensure that the resulting equation just has one variable, and it is in fact a quadratic. And often a sign of a quadratic is an x squared or a pair of x's being multiplied. Now, we don't necessarily just need to have x's if we're using a different variable because it makes sense for the equation, that's fine. But again, that variable would need to be squared, or we'd have to have a pair of those variables getting multiplied to, again, result in a single quadratic equation. Number 3, solve the quadratic equation using any of the steps that we have done in previous lessons, such as factoring, the quadratic formula, or using our graphing calculator technology. Finally, and this is really important, we need to make sure that the answer satisfies the question being asked. So what were we asked to find? We want to check that, make sure that our answer makes sense mathematically, plug it back in, make sure it works, make sure we can kind of work our brain through it and that it makes sense. And also just make sure that the words that it's asking, like was it asking for width or was it asking for length? Was it asking for both of them? That were like literally reading the question, thinking about what have we answered, and is that what was being asked. Finally, make sure that our labels are being used appropriately. In this video, we're only going to look at one example of creating a quadratic equation from a word problem, and here comes that example. So a rectangle has a width 3 centimeters longer than its length. Its area is 42 centimeters squared. Find its width. So the first thing I'm going to do here is draw a picture. So we have a rectangle. Then we know that its width is 3 centimeters longer than its length. So length is really what we're sort of in terms of. We have a length and we have a longer part, and that's known as the width. So I'm going to let the width be from here to here. So if this is then the shorter part, I can call that its length, and then its width is 3 centimeters more than its length. Now, I could have done this differently. I could have let w be my variable and then just subtracted 3 from the width to make the length. That would have been fine as well. So there's multiple ways to do this. But the important thing is I'm only using one variable, because in a quadratic equation, we should only have one variable. That variable will be squared at some point, but it's just one variable. Now, the next bit of information they give us, they say the area is 42 centimeters squared. Well, right away, is means equals. So something is going to be equal to 42 centimeters. Well, what is going to be equal to 42 centimeters? The area. Well, how do I find the area of a rectangle? To find the area of a rectangle, it's length times width, or base times height, or something along those lines. Well, I have a length. It's just L. And then I have the width, which I know is 3 centimeters longer than the length, or 3 plus L. Now, is this a quadratic? It doesn't immediately look like it because I don't see an x squared, or in this case, an L squared. But if I were to do a little distribution here and take the L times the 3 and the L times the L, I would end up with L3, or 3L, plus L squared equal to 42. And now, because I have that L squared, it's clear to see that this is, in fact, a quadratic. So at this point, I've basically gone through my first 2 steps. I've translated the words, and then I've ensured that it is a quadratic. And now I need to actually start solving. Well, how do we solve a quadratic? The first thing we need to do is make sure that our quadratic is equal to 0. And ours is not currently. It's currently equal to 42. So I'm going to do a little algebra here. Railroad track, subtract 42 from both sides. And these 42s will cancel out, leaving a 0 behind, which is what I wanted. And now I have 3 terms here. I've got my 3L, my L squared, and my negative 42 as my constant. I would like to put these in descending order, like ax squared plus bx plus c, or in this case, al squared plus bl plus c. So the L squared is what I want to have come first. And then I would have my 3L, which is positive. So I'm going to write plus 3L. And then finally my negative 42 at the end here. All right, so I have a quadratic. L squared plus 3L minus 42 equals 0. Now right away I'm seeing that my L squared has no a term in front of it, no coefficient. So there's an implied coefficient of 1, which means I'm going to try factoring this. I think that'll be the easiest way for me to solve it. Of course, you could use technology or anything else like that. But so in order to solve when there's no a term, I will start with my negative 42, my c term, and list the possible factors of this. And so I start with 1 and 42. I'm ignoring the negative for now. And then I have my 2 and my 21. Next, I am going to have a 3 and 14. And then I would have 4, but 4 does not go in evenly and have a remainder in it. 5 doesn't go in evenly. 6 goes in 7 times, and then 7 would be my next number, which is already written up here. So those are all my factors. Now, I know that I have to have one positive and one negative in order to multiply to be a negative 42. But if I look at my b term, which is in front of just the single L, it's a 3, a positive 3, which means I have more positives than negatives. So that means my bigger number needs to be positive, and all my smaller numbers are going to be the negatives. So I'm simply going to find which one will add up to become this positive 3 here. And lo and behold, none of them do. So not factorable. So I'm off to use some technology here. So I've cleaned up the board a little bit, redrawn my picture a little smaller, and I still have the equation L squared plus 3L minus 42 equals 0. I'm going to go to y equals on my calculator. I don't have an L button that I can use as a variable, so I'm going to default back to x. I have x squared plus 3x minus 42. This all equals 0, but here we're setting it equal to y so I can graph it. I hit my graph key. I'm going to go zoom 6 for a standard window. Now, I can't see my vertex on this graph, but I can see the two spots where the parabola would be crossing the x-axis, which would be my two solutions or zeros. So I'm going to look for those using second trace. I would like to select choice 2, which is my zeros. Press enter. Ask for a left bound, so I'm going to scroll to the left. I can see that it's about -8 is where it's happening. So I went to the left, I hit enter. Now I scroll just a little bit to the right of that x-intercept. I hit enter again. I do a guess. I hit enter. And I end up with an x value of approximately x equals -8.15 if I rounded to 3 significance. Now we can see there is that other x value happening over on the more right side of the screen. And so I run second trace one more time, looking for 0. I want to go to the left of it. I'm already to the left of it, but I'll just get a little bit closer here. And I hit enter. Then I go a little bit to the right of the intercept. I hit enter again, hit enter for my guess. And now I end up with a value of x equals 5.15. So at this point, I have solved the equation. I've solved the quadratic, and I wrote x equals, but I really should be writing L equals. And so I found that my length is -8.15 or 5.15. Now, one of these doesn't make sense with the question, and that's what I need to do at the end, is make sure I'm answering the question, that my answers are reasonable, all those sorts of things. And so what can't I have? Well, I can't have a negative length. It's not possible. So that one's out, which leaves me with a single value here. Now, can I put a label on it? Well, it's width. And actually, I just found L, which is length. So in order to actually find the width, I would need to add onto this. And so I would take the 5.15 and then add on 3 more centimeters, resulting in a width of approximately 8.15 centimeters. And that actually answers the question. Now, the last thing I'm going to do is just double check to make sure that this all mathematically makes sense. Now I rounded this answer, but I should still be able to get pretty close using this. And so we said our length was the 5.15. And then I'm multiplying it by the width that we had, which was approximately 8.15 centimeters. And I should be very close to 42 centimeters when I hit enter. And again, if I rounded to 3 significant figures, I'd be 42.0 centimeters, which is pretty much right on the mark. So again, what did we do? We translated the words into an equation. We made sure it was a single equation with a single variable that was in fact a quadratic with a squared variable. Set it up to be solved, set n equals 0. I tried factoring. It didn't work. So then I reached for my calculator with my technology. Once I got my answers, I eliminated any that weren't reasonable, checked my labels, checked it mathematically, and checked to make sure I was actually answering the right question, which I did here with my 8.15 centimeters. And that is our lesson on solving quadratics with word problems. Till next time.